Hey everyone, welcome back to my daily coding series. This is going to be number 89. I'm going to just start numbering them because I might do a couple per day. Okay, so I've never seen this before. It's called meeting rooms. Given an array of meeting time interval objects consisting of start and end times, where start is less than end, determine if a person could add all meetings to their schedule without any conflicts. Okay, so here we see that 0 and 30 conflicts with 5 and 10. Okay. And log in. We have 500 intervals. It's all positive integers. Okay. So an interval is an interval object. Okay. So my thought process is basically we're just going to see if there's any overlapping intervals. So we'll probably sort the intervals. And then we're going to go through the interval. So each interval object will be here. And then what we want to do, I don't know if I can just sort it like this. Would I have to say, would I have to sort it? Could I do like that? I don't know if that would work. I'm kind of curious. I don't know if I can just sort it. So my idea is I want to sort it by the start and then the end. Positional argument follows keyword. Yeah, so what is start and end? Are they integers? Okay, I'm printing it twice. I just don't know if intervals.sort will work. Yeah, because how do you sort? Yeah, so we can't sort it, but we can. So if I do interval dot start, intervals 0 dot start. Zero. Okay, so I want to sort by that. So can I not say intervals dot sort key equals lambda x dot start? Nice. Okay, so that works. Yep. And I can't say. Because if there's a tie, basically I want to. Does that work? I think it works. It's kind of difficult to test unless I could give it a custom input or create an interval object. But I'm just going to assume this works. Okay. So for those of you who don't know, this is lambda. Basically makes an anonymous function where the input is x and the output is these components of x. And then with the sorting method, you can pass in a key from which to sort by, which takes in a function. So this is a function without a name. Okay. So once they're sorted, I think what I'll do is iterate through them. And then Let me zoom out a little bit. So I'm going to iterate through them, and then let's start actually, let's say for I in range 1. So it could be 0 length. So I think what I'm going to do is return true at the end, and then here I'll look for exceptions. So I'll have something called like previous end, which will be intervals of 0 dot end. And then here we'll just say if there's a merge, or an overlap I should say, or a conflict in this case. So that would be if intervals of I of start is less than, and then so the equal sign right here, it's not considered a conflict if one ends at 8 and one starts at 8. Previous end. Then, so this is a conflict because, so for instance, if this meeting ended at 9, then we would say we start at 8, which is intervals I of start, but the previous one ended at 9. So that's a conflict. And then, so if it's not, then I think we just have to update previous end to be intervals of I dot end, like this. Okay, so let me try submitting that. Okay, the test cases worked. And we have a wrong answer. So in this case, the length, yeah, I should have considered this. The length is 0. So I could just put an if statement probably, because we have to get the first one. So if there's, yeah, I guess I could just do a little if statement. So if length of intervals is less than or equal to 1, then we can return true right away. All right, cool. So I also saw that there was a follow-up question to this. So I'm going to try that. I don't know how far I'll get because it is a medium. Okay, so here we have meeting rooms 2. Okay, so given an array of meeting time interval objects consisting of start and end times, just like the previous one, instead of returning true or false, we're going to find the minimum number of days required to schedule all meetings without any conflicts. Sorry about that. Okay, so we're going to find the minimum number of days required to schedule all meetings without any conflicts. All right, so what is a day? What is a day? I think it's like the number of groups we can have. So here, in this example, we see that 5 and 10 and 15 and 20. Okay. So whenever we have, yeah, this looks a little tricky. So whenever we have an overlap, basically, we have to put them on separate days. I don't think it's as simple as just counting the number of overlaps, though, because you could have, let's say, like 3 meetings that all overlap. Or let's say you have if you have like 1 to 4, 2 to 6, and 5 to 7. So these are your meetings. There's 2 overlaps here. This one overlaps with this one, and this one overlaps with this one. But you don't return. Well, in this case, I guess you do return 2 days. But yeah, okay. So in this case, it makes sense. But if this was like 7 and 8, then there's 1 overlap but you can't have all of these on the same day still. It's not equal to the number of overlaps, is what I'm claiming, because this has one overlap, but you still need 2 days. Yeah. Yeah, so in this case, what would I do? I'd probably take... So you want to basically separate it. So you could do... So the brute force approach would be you take all combinations and you pick the one with the least. So you could either put this on a new day or not. Yeah, so what can we do? So we know... So I'm trying to think of some way that we can know. Well, I guess something we could do is just whenever we find a conflict, we can maybe move it to a new day. So if we find a conflict, I guess we could move it to a new day. Which conflict should we move to the new day? Probably the one that... Or which meeting should we move to the new day? I would say the one that goes further into the future. Yeah, right. It's probably the one that goes further into the future. So then when we get to 7 and 8, we don't have to move it. What if this was... So, okay, yeah, so if it was 3 to 8... we would be... So if we move this one, that would be an incorrect choice. Well, let's say this is 1 to 3. That would be an incorrect choice, because now we still have a conflict even though we did 2 days. So what we want to do is move the one that has further... It goes further into the future. Okay, so now we have 3, 8. So this is still a conflict. It's still a conflict. So we would move it to a new day. And then, so I guess what you'd have to do, so a simplified approach would be you would scan every day and then find if any of them, if you can put this day on any of them. Yeah, okay. So I kind of like this a little bit. All right. So we'll have when you have a conflict, put the how do I say it? Meeting with the largest endpoint to a new day. All right, so let me make up some intervals. So let's say we have 1, 4, 2, 6, 3, 8, let's say 3, 5, 3, 8, and say 4, 10, 12, 13. Do these all overlap? All right, overlap. So, okay. So we look for a conflict. All right, we found a conflict. So between these two, 6 has the longest end date, so we'll move it. And then we're here. So we wouldn't really have to move it, I don't think. I think we just have a pointer. So let me articulate that. So, okay, so we'd put 2, 6 on day 2. This still collides, though, with 4. So at this point, we would, I guess, scan all of our days. This would have to go on a new day. it would have to. And then I don't know if each of these needs pointers as well. Okay, so our endpoint is 4 still for this day. So this would also conflict. So this would also have to go in a new day. Right? There's no other way to do it. All of these conflict. Yeah, every single one. Okay, then you get to 410. This does not conflict, so you don't have to move it. And then you get to 1213, and this does not conflict, so you don't have to move it. Okay, suppose instead... Okay, so that looks good. In this case, we just added them to the new days. What if we had 2? So what about if this one is like 4, 5, and like 6, 8, 7, 10. So I'm thinking here, now we don't have... There's less. I want to see what happens when not every single one is a conflict. So first 2, 6 is a conflict. 4, 5. So for this day, the pointer or the previous endpoint is still at 4. So this one's totally fine on this day. 6, 8. 6, 8. So the pointer... All right. So this is interesting now. So what if this was 4? Move to 4. 4, 5 is fine. What if this was... Four. Sorry. All right. So what if this was 4? So we have... all right, 17 minutes. All right, so we have 1, 4 is fine. 2, 4, we put on a new day because it's conflict. 4, 5 is okay with this one. So our pointer is at 4, 5 is okay. 4, 8. So 4, 8 is... So that one got removed. 4, 8 is not okay on this day. But we don't need a new day. We can put it on on this day here. So 4, 8. So it's almost like we want a... Like we need the next available day or something. And then here we have 7, 8. So 7, 8, and so this one also got removed. 7, 8 are our minimum. So like, it's almost like we need some data structure that tells us right now that we have 5 and 8 are our previous days. And then we see 7, we go through it, and we see that 5 is less than 7, so we can fit it on that day. And now this becomes 7. And then for 12, we see that 12 is... so this is interesting. So now we see that 12... Well, okay, so if we assume that it's sorted, we know that we will never need to really conserve space by doing that. We can put 12 on either one. My point is, like, technically it would be better if we did it on the 8, because then later if we encountered like something that needed to be on the 7, it would be fine. But yeah, because it's sorted, we could just put it here. So we need this data structure, which I wonder if it could just be... Yeah, I don't know. Maybe it could just be an array where every index like corresponds. So I'm going to do it again with this data structure in mind. So initially, I guess we could set it to -1 for day 0, or day day 0, day 1. Okay, so then we see that 1 is greater than -1. So now we put it at 4. Now for 2, we see that 2 is greater than 4, so we have to create a new one, which is also at 4 now. And now for 4, 5, we see that this one is good, so we don't have to adjust anything. 4, 8 is also good. No, we do have to adjust something. So 5 goes there. And now for 4, 8, we see, yeah. So this data structure, what do we need to be able to do? We need to find if there exists a value smaller than a target. So in this case, we have 4. Does there exist something that's smaller or equal to 4? Yes. So then we need to update it and update corresponding value. Then we have 7. So we see 7 is bigger than 5, so that's fine. So then we update this to 10. And now 12 and 13. 12 is bigger than 10. Okay, so I think I'll just do the simple way for now. So I'll just have an array, which, so I'll call it like, it's basically the last hour or last time of the meeting for every day. So I'll just call it like day end. And we'll start it, which is -1. So every index will be a day. So right now we're saying that day 0 basically has no conflict. Then we'll say for interval in intervals. We have to get, so the start value, we have to say for day end in day ends. If day end, let's use if day end is less than interval or equal to, right? Okay, so if it's less than or equal to, okay, so if the day end, what is day end? I'm gonna say day, just so it's not confusing. Days. Okay. So if the day is less than the interval start time or equal to, then we can add it to that day. So what that means is now that days of I equals interval dot end. So we've updated it to be the end value. If we iterate through this whole thing, and I equals the length of days and we didn't find anything, then that means days, we have to append the end value as a new day. Yeah, and then we can just print the length of days. All right, let me, I suspect that this is imperfect, definitely. Yeah, we didn't return anything. my output is 1. We expect 2. Yeah, let me see what yeah, let me trace this a little bit more closely. I'm not sure also too if this is like a valid way to check. I think I should have probably a Boolean. So we can assume it's true, and then if you find one, and then if that seemed to fix it. Let me just return it. All right. So this is slow. Also, we have this edge case. So the length can be 0. So obviously, if we have so I'll just do an edge case. We also have to sort it. Okay, I'm back. So we have to sort it as well. So we'll say x dot start, x dot end, like this. What was I going to do before that? I was going to do something. Oh yeah, the base case. So if length of intervals is less than or equal to 1, then we can just return. We only need 1 day. All right, let's see what happens now. Oh, well, I guess if we have no meetings, then we need 0 days. All right. All right. So here we're off by 1. So let me print the days themselves and see if there's anything that is... Oh, whoops, I forgot to save it as a test case. All right. So let's say added new day. And then here we'll say what did we do here? Updated existing day I, new end is interval dot end. All right, so 0 to 30, we updated the existing day. 25, so 5. I also may be interested in printing out days every time. All right. So let's just debug this and see where the error is. So that's expected. Print out so this is the interval that is coming in. Okay, 040 and days. Why is it? Oh. Okay. 030, we updated existing day. Next is 525, so that's conflict, so we should add a new day. Okay, so why? So we showed the interval and the days. updated existing day 0, new end. All right. So this is like the... All right, so I think we should show the interval first. Okay, so then we see it's 30, new interval. So now we added a new day 25. Now this interval is 10 and 20. So, whoops, neither one of these can exist because, so 10 can't exist in either day. So we have to make a new day. Now that day ends at 20. Now 18, same thing. And that ends 22. 23 does fit. It is sorted, right? Yeah, okay. So 23 does fit, so we updated existing day 2 and 3. All right, so we're only supposed to update one day. Yeah, right. So if we do this, we have to break out of the... So if we update a day, then we want to break out of it as well, because we shouldn't update multiple days. All right. Okay, so that's the... Let's see the time complexity, n log n. So I'm thinking you could also probably binary search instead of linearly doing it. Yeah, right. Okay, so that this idea works. We want to... So let me get rid of all of these print statements and think more algorithmically for a second. Yeah. Just want to see the... Okay. So we're creating these new days if we need to, and we're updating it. So the problem is this search. So we're obviously going to have to go through every interval. This part can be changed. So right now we just linearly search through it. It may be better if days... We don't really need to know the order of the days. So maybe instead of... well, what we could do is have maybe like a heap, I'm thinking, because we always want to extract like the minimum day. So instead of doing this, maybe we could pop from heap. So let's say x is the value, or let's just say, yeah, x. So x is like the minimum day, like the minimum end time of any day. So if x is less than or equal to interval start, then what we want to do is add interval.n to heap. We don't need to do anything with the old value. I think we just add interval.n back to heap. Otherwise, we need to add, so we add interval.n to heap as a new day, and we add x to heap again, because we didn't. All right, so in other words, let's change this to less than, and then we will add x to heap. And no matter what happens, we want to add interval dot end to heap. So my thought process here is we'll pop a number, and then if it's less than the interval start, that means we can fit it. Or sorry, that means if the minimum value is less than interval start. So let's say we pop out a 5 and we have a 7. I think I have my signs reversed. So in this case, we should grow it. So if the minimum is like 10, but our start time is 5, then we need to add a new one. So need new day is, yeah, I think, what if they're equal? If they're equal, we shouldn't grow. I think it's like this. Yeah, it should be like this. Okay. So let's say this if statement is never true. Then we will just pop and add, pop and add, pop and add. So it will never, our number of days will never grow. Which makes sense because if our minimum value is greater than our start time, that means there's a conflict. So now we add two things. So we add the original thing because we're not changing that day. And then we also add this new day. So let me, I think, yeah, it's just import heap queue. And then days will be a new heap. Oh man, I forgot it. I know how to heapify. Maybe heap queue dot. I think that will work. All right, so then what we'll do is for every interval, we will first heap dot heap pop. Or is it heap min? Don't we have to say like, no, days. I think it's, is it heap dot heap pop days? So this will be like minimum day. I'll just implement it assuming the syntax is correct. I think it's heap queue actually, heap queue. And then if it's not, I can figure it out. Okay, so we're gonna pop from the heap, and then we're gonna check if min day is greater than interval.start. We want to add the original back to the heap. So heap queue dot heap push. Yeah, I'll just assume it's like that. And then no matter what, we're gonna add the new day to the heap. Heap queue dot heap push interval dot end. And then at the end, we can just get the length of days. All right, let me see if this works. There may be syntax errors. Heap pop argument must be list, not none. All right, I'll be right back. I'm going to look up some syntax for this. Okay, I'm back. So I had this. I ran it with the right version, but so I had this. So heapify doesn't return anything. So days was a none variable, and then I was trying to pop none. So instead, what you have to do is create a list and then just heapify it, and it just does it. It doesn't return anything. So I think that's what I did there. Okay, so let's see if this works. All right, nice. So these methods, heap pop and heap push, I'm pretty sure are log n. So this is now n log n. Yeah, that was actually a really fun problem. I really enjoyed that one. Yeah, sweet. All right, so thank you guys for watching, and I will see you all next time.